Hi, I am Pranay Khangar and I would like to present an overview of Emertxe IoT Internship along with my partner Pratik Rangari. So let us start with the content. So here are the content. First we will be seeing C programming fundamentals, then embedded system, then embedded system types, and after that IoT, and then project requirements, then home automation project, and in the last the conclusion. So first we will be seeing the C programming fundamentals. So in C programming fundamentals, first is data type. So the various data types are character, integer, float and double. After that, conditional constructor. So conditional constructor are of three types, that is single iteration, multi iteration and then continue and break. So in single iteration there are if else and switch case. In multi iteration, for, while and do while. After that, the various operators. So the various operators are arithmetic operator, bitwise operator, logical operator, relational operator, assignment operator, and ternary operator. So after that, what is array? An array is a collection of data of same data types. After that, pointers. So in pointers, there are pointers bit fault, segmentation fault, while pointer. After that, pass by reference and pass by value. Then function and recursion. After that, strings, and then string library functions. So the various string library functions are length, compare, copy character, check string, check character, and then merge. So after that we have seen storage classes. So the various storage classes are auto, register, static, local, static global, and then external. After that, the various memory segments that we have seen are text segment, data segment, stack segment, and heap. Then preprocessors. So in preprocessors there are header files and macros. After that, the structures, and then introduction to C++ and OOPS. After that, let us see the embedded system. So what is embedded system? Any combination of hardware and software which is intended to do a specific task is called embedded system. The examples of embedded systems are car, TV, and refrigerator. So based on the performance and function requirements, embedded systems are divided into four types. So the four types of embedded systems are standalone embedded system, real-time embedded system, network, and then mobile. So let us see each of them one by one. So the first one is real-time embedded system. So what is real-time embedded system? It is strictly time specific, which means this embedded system provide output in a particular defined time interval. Further, real-time embedded systems are divided into two categories, that is soft real-time embedded system and hard real-time embedded system. In soft real-time embedded system, these are the kind of embedded systems in which time or deadline is not so strictly followed. If the system didn't give the result in the defined time, still result or output is accepted. And in hard real-time embedded system, the time and deadline of any task is strictly followed. Example of hard real-time embedded system are traffic control system, military usage in defense sector, medical usage in health sector, etc. So the second one is network embedded system. Network embedded systems are connected to a network, which may be wired or wireless, to provide output to the attached device. They communicate with embedded web servers through network. Examples are home security system, ATM machine, card swap machine. The third type of embedded system is standalone embedded system. In standalone embedded systems, they are independent systems which can work by themselves, and they do not depend on any host system. It takes input in digital or analog form and provides the output. Examples of standalone embedded systems are MP3 players, microwave oven, and calculator. After that, mobile embedded system. So mobile embedded systems are small and easy to use, and they require less resources. They are also preferred embedded system. In portability point of view, mobile embedded systems are also best. Examples of mobile embedded systems are mobile phones, digital camera, and MP3 player. After that, we have seen various types of memory. So various types of memories are RAM, that is random access memory, then read-only memory, ROM, and the third one is hybrid memory. So first, random access memory. So random access memory is a volatile, and it requires power supply to retain data. It can be written over multiple times. So types of RAM are of two types. First one is SRAM and second one is DRAM. So the second type of memory is read-only memory. It is a non-volatile memory and the data is not erased if the power is shut down. It can be only written once. So types of ROM are OTP, which stands for one-time programmable memory. Second one is EEPROM, and the third one is MASPROM. And the third type of memory is hybrid memory. It is a non-volatile memory, but it can be changed or overwritten for a particular number of time. So types of hybrid memories are EEPROM, and second one is flash. After that, we will be seeing what is Internet of Things. Internet of Things is the network of physical objects that can contain embedded technology to communicate and interact with their states or external environment. We can say that IoT is a technology which can makes any device smarter by giving them an ability to send data over the internet and allow the device to communicate with people and other IoT enabled things. So here is an architecture of IoT. So the various things are listed here, such as cloud gateway, IoT solution backend, etc. After that, we will be seeing the project requirements. So there are three different types of project. First one is control of garden lights, that is switch on and switch off the garden lights on the basis of sunlight intensity. Second one is temperature control system, which is switching heater and cooler on and off remotely. Switch heater off automatically if the room temperature exceeds 35 degrees Celsius. And the third one is water tank control, in which switch inlet and outlet valve on or off remotely. Switch inlet valve off automatically if the tanks fill up, and then switch inlet valve on automatically if the volume of the tank drop below 2000 liter. All the simulations are done using Arduino and Piximlab. So the Arduino requirements. So the various Arduino requirements are LED, temperature system, that is ADC. Third one is LDR, then serial tank. After that, Ethernet shield, then Blink IoT app. So we'll be seeing each of them one by one. So analog to digital converter. ADCs are of different types, that is flash ADC, pipeline, SAR, then dual scope, and then sigma delta. And ADCs are a very important peripheral in embedded system for real-time activities. And the controller understand only digital signals, so a real-time linear signal must be converted into digital form. After that, LDR sensor. So LDR stands for light dependent resistance. The resistance of an LDR decreases with increase in incident light intensity. This is also called as photoconductivity. A photoresistor can be applied in light sensitive direct detector circuit and light activated and dark activated switching circuit. Okay, so here is a diagram of LDR. After that, Ethernet shield. So the Ethernet shield basically allows the Arduino board to connect to the internet using the Ethernet library and to read and write an SD card using the SD library. And the Ethernet shield is fully compatible with the former version, but relies on the newer W5500 chip. To use the shield, mount it on top of an ordinary board. So here is the Ethernet shield. Then Blink IoT app. Blink IoT app is a full suite of software required to prototype, deploy, and remotely manage connected electronic devices at any scale. So, from the scale ranges from personal IoT projects to millions of commercial connected products. So, the various functions used in Blink IoT are blink underscore write, then param as int, then param as float, then param as double, then param as aster, then virtual write, vpin slash val, then timer set interval times function. After that, project solution. So first one is garden light. So input LDR sensor. The process is read the LDR sensor value and then based on the reading from LDR vary the brightness of LED, which resembles controlling garden light based on the availability of sunlight. And then output of the green garden lights are garden light. So LEDs. It is the simplest device which is used most on the embedded application as feedback. Second one is PWM. It is mostly used to vary the active time versus inactive time in a fixed time period. It is mostly used to control the average voltage of load connected. So the various functions used are pin mode, digital write, digital read, then delay and analog write. After that, the second one is temperature control system. The temperature control system consists of an heating resistance, an LM35 temperature sensor and a cooler. Temperature sensor LM35, and then the output is display temperature on. So in temperature control system, we read the temperature from the temperature sensor, that is the LM35, and display it on the CLCD. So the control to control the temperature of the system by turning on and off the heater and cooling through the Blink IoT mobile app. So the input is temperature sensor. The process is to read temperature from gauge widget and display temperature on CLCD. So the cooling control system. In cooling control system, the input is but button widget on Blink IoT app. The process is to detect the change in the logic level, and the output is if the button widget is at logic high, then turn on the cooler, and if the button widget is at logic low, then turn off the cooler. After that, heater control system. In heater control system, the inputs are button widget on Blink IoT. The process is to detect the change in logic level, and the output is if the button widget is at logic high, then turn on the heater, and if the button widget is at logic low, then turn off the heater. After that, threshold temperature control. The input is temperature sensor, and the process is to read and compare the temperature with 35 degrees Celsius. And the output is if the temperature is more than 35 degrees Celsius, then turn off the heater and send a notification to a Blink IoT app and display the same on the CLCD. So CLCD. So what is CLCD? CLCD is mostly used display ASC to character. Some customization in symbols possible. Then communication modes. Communication modes is of two types, that is 8-bit mode and 4-bit mode. After that, the various functions used are liquid crystal underscore I2C. After that, set cursor, then print, then LCD dot init. After that, LCD dot backlit, then LCD dot home, and then CD dot clear. After that, we will be seeing the water tank inlet and outlet valve control system. So in a water tank inlet and outlet control system, we have to read the volume of the water in the tank through serial communication and display it on the CLCD. Then we will be controlling the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Then we will be displaying the volume of water in the tank on CLCD. So here is the exact working of water tank. After that, let us understand how it works. So first one is displaying the volume of the water in the tank. So in input, that is the serial tank, then the process is to read the volume of the water in the tank by sending commands through serial communication, and the output will be to display the volume of water on gauge widget, and then display the volume of water on CLCD. So let's see the inlet valve control. In inlet valve control, the input will be button widget on Blink IoT app. The process will be to detect the change in logic level, and after that in output, if the button widget is at low logic high, then turn on the inlet. Then turn on the inlet valve by sending commands through serial communication, and if the button is at low level, then turn off the inlet valve by sending command through the serial communication. After that, let us see the same for the outlet valve. So outlet valve, the input is button widget on Blink IoT. The process is to detect the change in logic level, and the output is if the button widget is at logic high, then turn on the outlet valve, and if the button widget is at logic low, then turn off the outlet valve. After that, the next step is the control to control the volume of water in the tank. So the input will be the serial tank, and the process will be to read the volume of the water in the tank by sending commands through the serial communication, and the output will be if the volume of the water in the tank is less than 2000 liters, then then we will be turning on the inlet valve and send notification to the Blink mobile app and display the same on the CLCD. So the various functions used are serial.begin, serial.write, serial.write, then serial.write buff comma length, then serial.read function. In the end, I would like to conclude that using PiximLab simulator and IoT and Blink IoT, application, we have simulated home automation where LED temperature system, serial tank resembles light, heater, cooler, and water tank in real time. And now we will be seeing a demo which is presented by my partner Pratik Rangari.
This is the part two of my presentation. Now I will show you the code where I can tell you that small part was integrated with each other. It is the LDR sensor part. It is a main part where we assigned a pins, and it is a part of serial tank where we uh, assign a values on it, whole control, and this also, and temperature control system there where we assigned heater and cooler variables, and it is and now let me take you to the simulation part. As I mentioned it on snapshot, uh, this this is it. And here you can see my phone is connected, and this is the Pixel Lab. Uh, Here I am loading the hex file in the Pixel Lab simulator and connecting the serial tank. Here you can see that temperature is 27.37 and volume is increasing. Here you can see that volume is increasing continuously. Inlet is on, and when we turned off it, then inlet off, and you can see the volume over here, 2170, and you can see this here also. It is 2170 when we turned off the tank. Now you can see that outlet is on, then it automatically turn on. And I don't know whether it is visible you or not. It is showing the notification. Water volume in the tank is 3000 liter and full. It is full. So turning off the inlet valve. Here you can see it. And now I will demonstrate the example simulation of CLCD. Here you can see when I uh, push when I push it towards upside, then the LED is mm, eliminating more when I increase the luminous intensity according to it. And cooler when I wait a minute, let me show it on it. Yeah, now you can see I turned on the cooler, and you as you can see that cooler is turned on. Now maybe you can see that maybe it is visible to you. When I turned off the cooler, then it is showing the cooler off. When I turn on the heater, then it is showing heater on, and the temperature value is uh, uh, changing according to it. Here you can see that whole simulation. When I turn on the heater, the temperature is increasing gradually, and you can see that notification temperature is above 35 degrees Celsius. So turning off the heater. And that's all from my side. Hope you like it. Thank you.